Our next presenter is Stephen Mather. He's been working in GIS planning and related fields since 1998. And for the past 9 years, he's been the GIS manager for Cleveland Metro Park. So we're happy that he decided to flee the snow and come down to see us. Oh, well, okay. It's 70 everywhere this week, apparently. He has been interested in the application of computer vision to geospatial analyses since 2004 and has recently initiated the OpenDroneMap project, a project to bring together and extend a suite of open source computer vision software for use with UAS, or drones, and street level images. He is also the co-author of the Post-GIS Cookbook. Stephen?
I guess we'll do this. I'll try not to bounce around too much. So starting off with the link, this link will be at the end too, but for those who want to write it down, want to get to the presentation later, everything will be there. So was it 2013, we proposed OpenDroneMap as a project, and the idea was that that scalability is the long-term problem with UAV imagery. David talks about going out every day and flying. Not many people have that opportunity at this point, but that's not that far from the horizon for a lot of operations. At that point, having the computing resources and having the software licensing resources to actually process all the data that you're collecting becomes a barrier. And with that in mind, when we started our UAV program, and in advance of getting through all the federal processes to do it, we started this project. So it's an open source toolkit for processing drone imagery. You can also, take a camera and put it on a pole. It doesn't really matter what the platform is. It's all about the collection of the data, and it's modern photogrammetry, so fully automated stitching, digital surface modeling, and mosaicing. This is really about preparation for the robot takeover. I just want to make that clear, because some people, we think it's about important things like saving wildlife and other things, but really this is all about the future of robots.
I'm an alien from outer space. I'm a cyber girl without a face, a heart or a mind.
I'm pretty sure I can watch that on loop indefinitely. So this is about the future. This is about unprecedented levels of data collection, and that's in the foreseeable future, the amount of data that we can collect, whether it's through LiDAR scanners, whether it's through optical means, whether it's through just the GPSs on our handheld devices, the volume is huge, and we don't know what the future looks like. There's a lot of different scenarios right now. Actually, this kind of looks like the present in some places. But we know that, for example, Silicon Valley and other places are very interested in the question of how cities interact and how spaces. And this is what they think is a really good future for us. Haven't helped you if you're on a bicycle, by the way. They're not very good at detecting bicycles at this point. But that requires both sort of the real-time information, so all the sensors on the vehicles, but it also requires detailed information about those relatively static features, right? And I have a belief that process and that product cannot be siloed only in domains of only Google and Uber having all the geodata, but that domain falls back to individuals, to local level governance, and to other parties. So the origins of OpenDroneMap are in computer vision and photogrammetry, and let's see how this. So, like I said, we started at Cleveland Metro Parks. We're interested in plants and animals and conservation. We're a metropolitan park district in Northeast Ohio, so we preserve large tracts of beautiful wetlands. We have some coastal areas along the lake, and so the idea is that we go out and we. David's presentation is a great introduction of the absolute state of the art of doing this. But we go and collect imagery. We turn that into three-dimensional point clouds and meshes. Texture those meshes with the original photos, and then we can create things like orthophotos, digital terrain models, etc. We open sourced it from the beginning. It was based on open source software, and we really are committed to keeping it open. So long term, we expect to be able to use it for things like stream evaluation. We're already using it for looking at invasive and native plants. And this is an old video. It does not have all the current contributors by any means. But there's a really great community of folks working on it. So I want to really briefly go through that photogrammetric process. We're not going to go in depth. This is high level, but just so, and I'll stop the music. These are sort of the steps that the software goes through. This is opaque to the user. You can get in, you can fuss with the settings, but the process for the user is pretty simple. First thing is structure for motion. So structure for motion takes features. This is some dunes in California. Credit Michelle Tobias, and you can find features in each of the photos that match. And the process for structure for motion is to find those same features in a minimum of 3 photographs, and then through a sort of a magical statistical computer vision process that can then be constructed into a 3D point cloud. I say magical because I only have 20 minutes. Then you can take those initial matches and we can make a dense point cloud from it. So then we use those initial matches to sort of optimize our algorithm rather than trying to match everything all at once. And then that gives us the opportunity to leverage the information that we derive from that to create a dense point cloud, create a surface model from that, and then texture that mesh from the original photos. And then finally, it's easy enough now that we've got a 3-dimensional model to scan through that model and create an ortho photo from that, from the perspective of being directly above each of those spots. So questions you may be asking at this time. Great. How do I get started in collecting the necessary data sets for the robot takeover? And I'm glad you asked. So how to use OpenDroneMap. And so these slides are in here for you to review later. There's going to be some code here. There's not much. First of all, carefully. You can install OpenDroneMap on a Linux system if you're a Linux nerd, or you can do it via virtual machine via Vagrant. It's possible in macOS and Windows as well by doing Docker. I'd say Linux and Mac are definitely the easiest places to deploy. Windows is a little trickier, but we'll work on some documentation from that over the next few weeks. And then there's a nice web-based GUI developed by one of our community members in Florida, Piero Tofanen, that is an absolutely wonderful way to use it, and that's the demo that I'm going to do at the end here. So usage, clone it, run the configure script, set your path variables appropriately, and run. It's literally that easy. It creates a directory structure of all the outputs once it's processed through everything that you can then load, including GeoTIFF and a LAS file, similar to how LiDAR data gets stored. And then if you want a user interface for it, we've got Web OpenDroneMap. And Web OpenDroneMap, basically you load up the images and you say, go, and it processes it. Right now, I should say there's no, sorry, just for a brief moment there, I thought I saw someone from the project. So right now, there's no sort of hosted service for this right now, but there's definitely people interested in hosting this. There are definitely people who can help. So if you need it set up and you don't have the technical side, but you have the need, there are folks that can help with that. And then the output is an orthophoto. So here's our orthophoto over a test data set in Switzerland. And then there's a 3D viewer in it as well so that you can view your assets before you download them and use them on the desktop or do all your additional processing. So funding and the future. So like I said, Cleveland Metro Park started the project. American Red Cross actually spent some time, effort, and money to integrate it into the portable OpenStreetMap project last year. And their use case is they want to be able to go, so you've got, everyone remembers the Ebola crisis. They want to map those places before the next outbreak of Ebola, so that they can actually trace people's origins. So when someone shows up at a hospital sick and you say, where have you been? And they say, I'm from such and such, I came here, I've been these places, that those places are actually traceable on the map. Once you do that, the problem of rapid spread of something like Ebola goes away. And we saw that in Nigeria. Nigeria really didn't have a breakout like most of the a large portion of West Africa because they could do that tracing. So they're going out. They're putting all their data into OpenStreetMap. They have a project called Portable OpenStreetMap where they go out and map all those places. They want the ability to really rapidly throw a drone in the air, map a village, process that imagery, digitize all their assets. They could be offline for 6 weeks, 8 weeks, but come back to networks, upload that in OpenStreetMap, and then use that for incident responses in the future. And then we were fortunate enough to secure funding from the Humanitarian Innovation Fund to also do extensions to OpenDroneMap, and more on that, but all related to improving the underlying algorithms and improving the interface and deployment of it so that a wider audience of folks can be users. So additional future stuff. We got, in the next 6 months, we're looking at quality and robustness improvements. So really looking at comparing this to all the closed source solutions, comparing it to laser scans, and finding out, can we see that centimeter accuracy? Making sure that it's scalable. This is the original purpose of the project. So we need to reduce the memory footprint and do data partitioning. One of the problems that people are running into now is, all right, I've done flights. I've done 4 flights a day every day for the last year. How do I process all my imagery? So we're looking at. I'll give you a tangible example in Zanzibar, in Tanzania, in East Africa. There's a project called it's the simply named projects are the hardest ones to remember the names of. I think it's the Zanzibar Mapping Project, but there, a portion of that is basically to go out every day with 6 EB drones and map all of Zanzibar, 2,100 square kilometers. 10 students at State University of Zanzibar have been doing that now for, 8, 9, 10, 12 months. They're nearly complete, and now they have these massive data sets that they need to put together into one thing. And so there are 2 problems that you run into. They've done a great job all along the way processing the imagery as they're going, but then you run into the problem of having a single unified model. So I want to do hydrologic modeling on this, right? Oh boy, now I need to make sure all my Z's match, right? Similar problem in Dar es Salaam, also in Tanzania. They want to map the entire city with commodity drones, and in the tests that they've done, they've run into the problem of, all right, my Z's are accurate. I don't have RTK on all my drones, but I want my Z to match at the end. Massive amounts of data. How do we handle that? So those are some of the problems that we're looking at. And then just recently, because I had too much sweet tea 2 nights ago, we're very close to having automated DTM extraction added and classification added to the tool chain. So this was a test site thanks to Anna at Center for Geospatial Analysis at NCSU. This is a data set. This is, you can see, let's see if I can have my mouse here. There we go. We can see a building here. We can see the trees. And this was me sort of playing around with what can we do with other open source projects to filter out the non-ground points. And it's been pretty successful. And then here's the derived digital terrain model. Okay. So also the future is, of course, web and usage. It's not all about the processing. Now that we've got DMs very close to being in the pipeline, we want to do display. We want to be able to do volumetric measurements in the browser. Ideally, we do mission planning so that this is a closed loop. You go out, you plan your mission, you process the data, and all in one thing. Part of that would actually be having a mobile app for autonomous flight and integration into other open source packages like QGIS. And then thinking of massively scaling things. How do you then, all right, now let's think, in the future there's a service that actually provides this. How do you take those massive amounts of point clouds and actually serve them back to the user? So there's some really great open source projects, including Entwine and Greyhound, which are designed specifically to do that. And if you guys were here 2 years ago, Howard Butler, who's the leader on Entwine and Greyhound, was here talking about that project. They've made really great advances. I mean, they were in awesome places 2 years ago, but that's a huge opportunity. And then most people are now familiar with OpenStreetMap. You may or may not have heard of OpenAerialMap. OpenAerialMap is about creating an open licensed aerial imagery data set for the world. So for processing drone imagery, we should be contributing back to that. Okay, so it's not a bad idea to end with a live demo because all the slides worked. So we'll see what we can do here. So this is what web OpenDroneMap looks like. One thing that I didn't say when I said, how can you contribute to the robot takeover? If you do have imagery, I can give you a login to this. This will be up for a couple weeks, and you can log in, you can upload your data, and go through the interface. So if you want to just start playing with OpenDroneMap and you don't want to have to go to the command line to do it, let me know. I'll get you a login, and you can play with this. It's a queuing system, so if there are lots of users, you may have to wait a couple days for it to for the machine to catch up, but that is an option. So roughly, things are organized into projects. So I can create a new project. Go call this mid. I don't know if I can do that. Oh, good. And now I just say upload images. Choose my images. And we'll have an upload process. It's really fun to watch the progress bar. So these will upload. We can, if we're advanced user, we can just say save, and then when it's ready to start processing, it'll start processing. Or for advanced users, we might say, oh, you know what, I really need to enable that one feature that I need. And say, all right, I'm going to enable that feature. Or if you go onto the boards and you're like, I didn't like the results, and someone says, oh, use this flag, that's where you find the flags. You just go to advanced and say save. And then this will go. So we've got 5.5 minutes. We're just going to watch this. Just sort of. I'm going to turn the music back on, though. All right. So when it's done processing, this will be like a cooking show, I guess. When it's done processing, then we can actually look at while it's processing, I should say. We have all the output here that we can look at if we choose to. We can download all of our assets either individually based on the kind of asset. So there's the GeoTIFF, there's the last file, or we can just say everything. I just want a zip file of everything. Give it back to me. We can view it in situ. So let's go ahead and view that ortho photo. It'll zoom right to the site, and we can zoom in on it. By the way, you'll notice. You may or may not notice there's some gradient issues with this. We fixed this. I just didn't pull in the latest, so there's like some strange banding in there. Don't worry, it looks beautiful in real life. Well, it will in a couple weeks anyway. And then we can also view this in 3D. So let's go ahead and go to the 3D viewer. Using a trackpad is just special. All right. And so here's our 3D viewer. So we can actually view the underlying data. Right in the browser, easy to use. Upload and go. Download. I think that's everything. Yes. So thank you. No. Not yet. Not yet. It is not yet a. There has not. No one from the community has volunteered it yet, and it is not yet funded. But happy to add it. It's definitely on the wish list. So with the existing funding we have, the focus for the Humanitarian Innovation Fund funding, which is the primary piece of funding that we've secured for it, the focus is on algorithm improvement and usability. I don't know. It's interesting. There's a lot of benefit to running on CUDA, and but I think we really have some algorithm fixes that we need to do first as far as memory management before we can throw massive amounts of processors at it. And CUDA's, I think what we're going to run into, at least theoretically what we'll run into if we add CUDA before we fix the other issues is we'll have so many cores and not enough memory for all those cores. But I think we're probably 4 or 5 months out from solving the scalability issues as far as just sort of raw scalability, and then we can think very seriously about CUDA. Mm-hmm. Yeah.
Do you have any way of inputting in ground control point correction at this time?
Yes, we do. So on the command line side, basically you just create a text file. It's a really, really simple text file with your pair's coordinates and image coordinate and geospatial coordinate and the image name. We are working on building an interface for that so that we can put it into web OpenDroneMap so that people can manually, can interactively create that so that you can match it to existing imagery. So you don't necessarily have to have like a field survey of ground control points in order to do it. That project is, we've got basically the first draft of that interface done. And I think I promised my feedback on it today, so that's what I'm going to do after. That's what I'm going to do during lunchtime. And there was something else related to that. Ground control points. I don't know. I think the robots are distracting me. Yeah.
I know we've got some certified photogrammetrists.
Yeah.
In the house. So
Should have been more nervous.
Like orthophoto and things like that. How does licensure?
Oh no, I'm not touching that. So within Cleveland Metro Parks, I can talk about we've got surveyors. We've had conversations. How do I put this? We have a continuing dialogue about what we're doing and how we're doing it. Someone laughed as though that was a really diplomatic way to say it. No, we're friendly. We're friendly. But it is one of the really, really interesting questions when we look at the convergence of all the really vague hand-wavy things that GIS has been doing for decades, as the precision of that converges upon the same numbers as the accuracy of whether a survey. There are sticky questions, and I'm not qualified to answer licensure questions. But it's something that we continue to look at and think about. Was that a safe enough answer?
I just figured it would come.
They were holding back. They were being nice.
These creating the tools are not the ones that are necessarily selling the data.
That's right.
When you go to sell that data, it's commercial. In North Carolina, we've got board examiners for engineers and surveyors use this as survey. They know what you make a look at photo, they know what you derive an elevation model, they know what you take measurements on.
Yeah.
That is deemed by the Board of Registration and Survey.
Mm-hmm. So really, I just want to repeat it in the microphone. It's a short version. So there's the software side, and there's the processing and commercial delivery of data, and those are different things.
But I would take it also to include there's also the acquisition side.
Mm.
You know, if they acquire the entry,
Yep.
that's not considered professional service.
Mm-hmm.
I understand.
Okay. So acquisition of imagery, not a professional service.
Yeah, but either that, acquired entry, you swear with what North Carolina requires.
Yep. Yep.
And then when you take it from that and start processing and using these geospatial products,
Mm-hmm.
come under the North Carolina Board of Engineers,
Yep.
Board of Examiners for Engineers and Surveyors deems as a professional service.
And I should say, when we actually go through, when we use drones for mapping in Cleveland Metro Parks, our first step is to send surveyors out and grab ground control.
If you're in
And
North
that's-
Carolina, there's a public agency exemption.
Mm.
You can practice survey.
Oh, interesting.
If you're a government employee. I've got a letter from the board of examiners that says so.
Well, I know what the rule reads, and it has public utility services, but the public municipalities were taken out, I think, in 2015.
So before we get too deep, because I think this is an important conversation. So one thing that I would ask photogrammetrists, folks in the survey field in the room to do is engage with these projects. Like this is, because we need you. one of the big questions that sort of occurred to me as we were initially building the project, one of the problems that that we run into is ridiculous low levels of precision without, how do you, you fly all of Zanzibar, how do you make sure that that actually is, that actually becomes a product that meets the specifications of the kind of use that you need? And that's a problem that, from my perspective and coming from the hand-wavy planning side of things, never becomes an issue. But once people start building things on top of it, it becomes a very real issue. And we need the engagement of the community that's been working on this for longer than we've been thinking about it as part of that process.
Thank you very much.
Thanks.